So starting with number 1, we're asked to determine whether the given value is a statistic or a parameter. Now remember, statistics come from what? Samples. And parameters come from populations. So in number 1, we're told that a sample of 120 employees of a company is selected. The average age is found to be 37 years. So this number, 37 years, is that a statistic or a parameter? It's a statistic because we're told that it's from a sample. On number 2, we're told after taking the first exam, 15 of the students dropped the class. The class is our population of interest. So these 15 students that dropped would be a parameter. You didn't see the word sample anywhere in here. The class is what we're talking about, so that would be our population. On number 3, after expecting all of the 55,000 kilograms of meat stored at the worst sausage company, it was found that 45,000 kilograms of the meat was spoiled. Here we're told all of the meat at the company. So all the meat at the company would be our population, so the percentage that's spoiled would be A. On number 4, we're told a health and fitness club surveys 40 randomly selected members and finds that the average weight of those questioned is 157 pounds. That 157 pounds, would that be a statistic or a parameter? It's a statistic because they surveyed just a few of the members of the club. That would be our sample, the 40 that they surveyed. On number 5, it's multiple choice. It said, which of the following sample types should you always regard as unreliable? Voluntary response samples are always unreliable. They're usually biased, so that's why we would select that. Number 6, a pollster randomly samples 159 Democrats, 151 Republicans, and 16 independents, all registered voters in Metro City, and asks each poll participant which mayoral candidate he or she prefers. Identify the kind of sample that the pollster is using. Would this be voluntary response, sample of convenience, cluster sample, or stratified sample? Why is it stratified? It is stratified. Remember, stratified because we took the 3 groups of the population. For voters, you're either Democrat, Republican, or Independent. We're assuming there's no libertarians in this city. Those are the 3 different classes of voters, and then we take a random sample of each of those classes of voters in the city. That's why this one is stratified. If you take some out of all the different groups, that would be stratified. All right, number 7, a middle school student passes out leaflets to the adults at a school function. The leaflets ask the recipient to indicate whether they believe in anthropogenic global warming. The bottom of the leaflet indicates that the completed leaflet should be returned to the student. Identify the type of sample that is being used here. It's not cluster because we didn't divide our population into groups and take all of one of the groups. It's not systematic because we're not counting off a regular increment. It's not stratified because we didn't, once again, divide the population into groups. This would be a sample of convenience. They go to a meeting, they hand out the flyers to people that are there in attendance already, and then they ask them to fill them out and turn it in. It's just convenience. Number 8, by visiting homes door to door, a municipality surveys all the households in 89 randomly selected neighborhoods to see how residents feel about a proposed property tax increase. Identify the type of sample that's being used. This is similar to the example that we did in our notes, correct? The households would be the groups, and we took a random sample and surveyed everybody in that group. So this would be a cluster sample. We divide the population into households, and then we randomly select the households and survey everybody in that household. So that would be a cluster sample. Number 9, an electronics manufacturer tests every 1,000th cell phone to verify that it is functioning properly. Identify the kind of sample that's being used. Systematic. This one's systematic because we're taking every 1,000th cell phone, so in regular increments of 1,000. Number 10, identify which of these types of sampling is used: random, stratified, systematic, cluster, or convenience. 49, 34, and 48 students are selected from the sophomore, junior, and senior classes with these many students in each class. So we're taking a random sample from each of the classes. What type of that's stratified. If you take a random sample from every group, that's what stratified means. Number 11, a sample consists of every 49th student from a group of 496 students. What would that be? If you're going in regular increments, that's systematic.
What if it's not regular?
What do you mean?
What if it would say that, but it's like it goes off?
So
The next one, instead of it being 49, next one will be 50.
then it would just be a random sample. If it's going to be, the question was, what if it's not taken at regular increments? Let's say they did the 7th, the 13th, the 11th. Then that would just be a random sample. Systematic has to be at regular increments. Number 12, a pollster uses a computer to generate 500 random numbers, then interviews the voters corresponding to those numbers. What would that be? That's just purely random. Number 13, to avoid working late, a quality control analyst simply inspects the first 100 items produced that day. That's definitely convenient. You were trying to keep from working late, you just take the first thing that's available. Number 14, an education researcher randomly selects 48 middle schools and interviews all the teachers in each school. That's cluster. We take a random sample of schools and then survey everybody in the schools that are selected. That would be cluster. Cluster and stratified sometimes get confused. In a cluster sample, you take all from a random sample of groups. In stratified, you take a random sample from all of the groups. Number 15, determine which of the following describes quantitative data. The name of a chemical sample, the mass of a chemical sample, the color of a chemical sample. And we're looking for quantitative. Quantitative is numbers, it's numeric. So the name is not a number, the mass, though, is a number, and the color is not a number, so this would be just number 2. Number 16, determine which of the following describes qualitative data. This one may or may not be a number, but it definitely describes a quality. The volume of a shipping container in gallons, the name of the material from which the container is made, the shape of the container. A would be the name, which is definitely qualitative, and the shape, which is also qualitative. So it would be A. Any questions about that one? The volume would be a quantity. It's a quantitative measure. Number 17, determine which of the following describes nominal data. Nominal data is name only. It can't be ordered or numeric or anything. All right, number 1, my favorite days of the week are Friday, Saturday, and Tuesday. Number 2, my favorite day of the week is Friday. My second favorite is Saturday. My third favorite is Tuesday. C. It would just be the first one because now I've ranked them in order, most favorite to least favorite. Number 18, determine which of the following describes ordinal data. In the horse race, Betty's girl won, Mr. Ed placed, and Wabash showed. In the horse race, I bet on Betty's girl to win, Mr. Ed to place, and Wabash to show. Which one would be ordinal?
Does ordinal mean like an order?
In order. They're both in order, right? If you win, place, and show, that's an order. I'm not familiar with horse racing, but I have a feeling one of them is first, second, and third. And then here, this is the order that you bet on them to come in. So both of them actually are ordinal data. Now we have to determine whether the given value is from discrete or continuous data sets. The number of freshmen entering college in a certain year is 621. That's discrete. Remember I said if you see number of, it's going to be discrete. The temperature of a cup of coffee is 67.3 degrees Fahrenheit. Continuous, because temperature is measured on a continuum. It could be 67.3 to whatever level of specificity you want. Temperature can be measured on a range of values. But the number of freshmen, I could either have 621 or 622. There wouldn't be anything in between 621 and 622. That would be discrete. But temperature, I could come up with any number of temperatures between two given temperatures. Number 21. The weight of Bill's pack as he sets off on a backpacking trip is 48.3 pounds. Weight is measured on a continuum as well. It's not discrete. The number of limbs on a 2-year-old oak tree is 21. That's discrete. You see the word number of. Number 23, the following is a pie chart that presents the percentages spent by a certain household on its 5 largest annual expenditures. What percentage of the money spent was spent on food, housing, and utilities? So here's the percent spent on food, 27.7. Here's the percent spent on housing, 24.8. And then utilities would be 12.9. All I need to do is add these numbers together, and when I do that, I get 65.4%. So this would be D. It would be these 3 groups right here, food, housing, and utilities. Number 24, the following frequency distribution presents the frequency of passenger vehicles that pass through a certain intersection from 8 a.m. to 9 a.m. on a particular day. So here's the type of vehicles and then how many pass through the intersection between 8 a.m. and 9 a.m. So there were 15 motorcycles, 85 sedans, 50 SUVs, and 25 trucks. We now need to find the frequency bar graph that represents this data. So on A, we have fewer motorcycles. We needed 85 sedans. That's too few motorcycles. We needed a frequency of 15. Halfway in between here is between 0 and 20 is 10. So that's not it, right? You need 15 motorcycles. On B, it looks like we have 15 motorcycles, 85 sedans. Looks like that would work. And SUVs, we needed 50. If we go across here, that does look like 50, and then 25 trucks. And if we carry that line across, it looks like that would be 25 trucks. It looks like B would be the correct choice. This one's not it because it has too few motorcycles. This one only has 10 motorcycles, so that wouldn't be it. And this one only has, looks like 5 motorcycles, so that wouldn't be it. So the correct answer here would be B. But you see how the frequency is the height of the bars for each of these different vehicles. The frequency is just the count. On number 25, we're told the following frequency distribution, same thing, different numbers. What is the relative frequency of the SUV category? What does relative frequency mean we need to find? The percentage. So that means that I need to take these numbers and divide them by the total number of vehicles that pass through. How do I get the total number of vehicles that pass through here? Add them all up. Can anybody do that for us? Can somebody do that for us, please? So you got a total of 209. So I need the relative frequency for the SUV. So to find that, I would do 78 divided by 209. And when I do that on my calculator, I get 0.373, it looks like. And that would be B. Relative means a percentage or a decimal value. So you take the count divided by the total.
So when the test, it won't necessarily have the percentage sign next to it?
Right,
Okay.
it's just a decimal.
Will it tell us if we have to, oh, well, they're all multiple choice.
They're all multiple choice. If I wanted a percent, these numbers would have had percents.
Will it ever say it though if it needs to be rounded lower?
You'll round according to what the answer choices are. Don't look at this and say, oh, relative, that's the only one with a percent, that's it. The relative frequency can be written either as a percent or as a decimal. To change that decimal to a percent, all I'd have to do is move that decimal over 2 places, and I could have said that's 37.3%. If my answer choice would have been 37.3% instead of this decimal, that's the one I would have gone with. If you have both, I'm not going to make you pick. I'm not going to do that, where I have both the decimal and the percent that are correct. Number 26, classify the histogram as skewed to the left, skewed to the right, or approximately symmetric. This is the shape of the histogram. Remember, I told you can identify these that are skewed because this tail of this distribution is going off to the right. So this would be skewed right. Symmetric, remember, is a shape that looks like that. Symmetric and bell shape, we called that what? Normal. This would be a normal shape. This one's skewed right. A skewed left distribution would look something like.
For this test, are we allowed to have a sheet
Mhm.
with those and
Mhm.
stuff? Okay.
Yeah, you'll also want to keep a calculator sheet out. We're going to get to the calculator problems in just a minute. Number 27, 100 students are shown an 8-digit number on a piece of cardboard for 3 seconds, and they're asked to recite the number from memory. The process is repeated until the students accurately recite the entire number from memory. The following histogram presents the number of trials it took for each student to memorize the number. So here's the number of trials. Only 2 students got it right the first time, 3 students got it right the second time, 9 students got it right the third time. So it's looking like most of the students took at least 5 trials to get it, and then finally, after 8 tries, the last 3 got the number memorized. So how many students memorized the number in 3 trials or less? So here's 3 trials or less means these right here. So that's going to be these students right here. So to answer this, I would just add this up. 9 plus 5 is 14, so that would be 14. 3 trials or less. What if I asked how many students got it in 6 trials or more? What would I do? I would add these numbers up. What if I said how many students got it in 4 or 5 trials? I would add those numbers up. Number 28, the following frequency distribution presents the weights in pounds of a sample of visitors to a health clinic. So here's the classes for the weight, and then how many people were in that class of weight. What is the class width here?
7.
It's 8. How do we determine the class width?
Subtract those first 2.
Subtract, look at the difference here. 138 minus 130 is 8. 146 minus 138 is 8. You just subtract consecutive numbers. If you want to subtract these 2 numbers, you can do it. 145 minus 37 is 8. The class width is 8. It's the number that you would add to go from one number to the next, going down the column. 29 says construct a stem and leaf plot for the following data. If we're going to do this by hand, what do I suggest you do first? Put them in a list in your calculator and then get the order correct. So let's go ahead and do that. We'll put this data into a list in our calculator. How do I get to the list on my calculator? Stat, enter. And now I'm going to type the numbers in. Once you have your data into the list, what do you need to do? Second mode is quit. Now what? Hit stat, and we want to sort our data from smallest to largest, so that's going to be sort ascending. To tell your calculator what list to sort, we hit second 1 to put in list 1, and it says it's done. We don't know it's done until we actually go back in and look at the data by hitting stat enter. So on the ones, I need to have a 299. So let me look at my choices right fast. 1, I don't have a 2 there, so that one's not it. Here I have a 299. Here I have a 29. That's not it. Here I have a 299. Now I need to go down and look at the 2s. So on my 2s, I need a 0, 1, 2, 299. 0, 1. Do you see how I'm getting these numbers? It's the number that's in the ones digit where my tens digit is a 2. So I need a 0, 1, 2, 299. 0, 1, 2, 299. This one's it. That one's not it because it doesn't have the 0, 1, 2, 299. It's missing the 1. So this would be your correct choice. Does that make sense? Now, I did have a question emailed to me over the weekend. Somebody was doing the homework and they saw 2 1s and 2 2s for the stem. Do y'all remember that homework question? When that happens on your stem and leaf plot, if you had this 1, 1, 2, 2, 3, 3 for your stem, then what that means is this first one would be for the digits 0 to 4. So it would be 10 to 14 would be the data values, and then 5 to 9. So 15 to 19 would be the stems over here.
And if they're in front of the 0, it'd just be 0 to 5.
From 0 to 4 and then 5 to 9. Yes. So if you have a stem that repeats like this, then that means that you're going to divide those 10 digits, 0 through 9, in half, and the first half from 0 to 4 will go on the top one, and the next half of the digits for the ones unit would go on the second one. Number 30 says find the mean for the data set. What's the easiest way to do this on your calculator? Type in the numbers, and then we're going to use the calculator to do it. So I'm going to put these numbers in list 2. 28, 14, 25, 19, and 20. Once you have your data in the list, what do? Second quit. Now, to get the mean, the easiest thing to do is hit second, stat, go over to math, and then number 3 is the mean. And I want to find the mean for the list of data that I have in list 2, so that would be 21.2. And how I did it was I put my data into a list, and then I hit second, stat, and then I go down to mean. And then you're going to have to put in the number that corresponds to the list that your data is in. I have another way of finding the mean. Do you remember what that is? What else could I have done? Stat, calc, enter, and do the one variable stats for the data that's in list 2. And that gives me a whole bunch of information, but it does give me the mean is 21.2. I don't care which method you use. So you could do this, or you could do stat, calc, enter to get the one variable stats. Stat, calc, enter will give you the one variable stats. This one just gives you the mean only. This is a small set of data, and on number 31 we're asked to find the median for the following data set. So let's just do this one by hand, shall we? What's the first thing I need to do? Put them in order from smallest to largest. So I'm going to have 13, 17, 18, 24, and 25. And then the median will be what? The one in the middle. So that's going to be 18. Now we have an even number of data values. We still do this the same way. We put these numbers in order from smallest to largest. So what's my smallest number? 13, then 19, 22, 24, 29, and 32. Now, because I have an even number of numbers, I've got to take the average of the two middle numbers, and when you average 22 and 24, you get 23. It's the average of the two middle numbers. On number 33, we're asked to find the mode. What does mode mean? The number that repeats most often. What number is repeated here? 21, because I have two 21s. On 34, we're asked to find the mode of the data set from a stem and leaf plot. I don't have any numbers that repeat for the zeros. For the ones, I have two 4s, and for the 2s, none of the numbers repeat. So what will be the mode for this set of data represented by this stem and leaf plot? 14. Because remember, the stem is the tens unit, the 4 would be the ones unit. So I have two 14s for this list of data. What about on 35? What do I get for the mode? There's a 7.35. And I think that's the only one that repeats, so that would be 7.35. We can find modes for qualitative data. The following data represent the ice cream flavor choices of 20 diners at a college cafeteria. Which flavor ice cream is the mode? What do I need to do to find the mode here? Find the one that's used most often. So let's make a table with all of our different ice creams. So we have Moose Tracks, Rocky Road, chocolate, vanilla, and chocolate chip. Oh, there is 2 chocolate chips. So we'll do chocolate chip. So y'all call them out, going across or down. Go read down the columns, and I'll just keep a count of which one, you know. We have Moose Track. And that's all of them? So it looks like we had 7 Moose Tracks, 5 Rocky Roads, 2 chocolates, 4 vanillas, and 2 chocolate chips. So the mode here would be Moose Tracks. But you see how you do that? You just make a table and fill in the count, and whichever one's the highest, that's the mode. 37, what would be the sample variance? Sample variance for the following data set. How did I tell you to do the variances? Put the data into the calculator. So we're going to have stat, enter, and I'm going to put this in list 3 just so I can keep these numbers from my night class. So we've got 22, 22, 12, 23, 17, and 21. Then we go to the home screen. Because this is the sample variance, we can find this using the second stat math. So we're going to do second stat math. Remember, this is for sample data, and the variance is number 8, and I want the variance for the data that I put in list 3. So I hit second 3, then we hit enter, and we get 20.5. So the variance, the sample variance is S squared. That would be 20.5. For the sample standard deviation, I've got a different set of numbers. So I'm going to put these in my calculator, and I'll put these in list 4. We have 23. Then we hit second quit. We have the sample standard deviation, so I can do the same thing. I'm going to hit second, stat, math, and now I want the standard deviation for the data that's in list 4. So I hit second 4, and that gives me 5.8. S here would be equal to 5.8. Yes, sir.
You also find it by going to calc and one variable.
You can do the one variable stats to get the standard deviation as well for the sample. Matter of fact, if we did that, if we did stat, calc, enter, and I do this for the data that's in list 4, I end up with the sample standard deviation being 5.8, which is what we got. This number right here is the population standard deviation, so you would not want to choose that one if you use the one variable stats. The one variable stats is the only way to get the population standard deviation and variation. So here we're going to have to do the one variable stats because we're looking at population variance and population standard deviation. Pay attention to how I find the population variance for number 39. So we put the data into the list. So we hit stat, enter, and I'm going to use list 5, and I have 13 and 21. Now, because I want the population variance, I have to do the one variable stats. So I hit stat, go over to calc, and hit enter. My data was in list 5, so I hit second 5. And I don't get the variance, but I get the population standard deviation. What's the relationship between the variance and the standard deviation? Square it. The population standard deviation is a lowercase sigma. The variance is sigma squared. So what I need to do is I need to square this number right here. Because I don't want to make a rounding error, though, I'm going to have to go into this variables key, the variables feature, and grab the population standard deviation and then square it. So I'm going to go back to my home screen, and I hit variables, and the variables that I want are statistics, and the statistic that I want is number 4, the population standard deviation. And then I hit this button right here to square that number, and I get 20.8? So our population variance is 20.8. On number 40, we're asked to find the population standard deviation. So I put the data into my calculator, and I'm going to use the data. I'm going to put this in list 6. So we've got 21, and then we go back to the home screen. What's my next step going to be?
Over the
Stat, calc, enter. And now I want the data that's in list 6. So I'm going to hit second 6. And which one of these numbers do I want? It's 3.31, the population standard deviation. And they want us to round it to 1 decimal place more than the data, so that would be 3.3.
What if the one beneath it says a different one? Do you have to make a match?
What do you mean?
Like you use list 6, right? On mine it says list 4 or whatever, and then underneath it where it says
Frequency list,
Yeah.
you leave blank. You only use the frequency list if you're doing weighted data, or if you have like a frequency table where you have to use the midpoint and then a frequency. We don't have frequency, we have a list of raw data, so we leave this blank.
And then you just hit calculate.
And then you hit calculate. Yes, ma'am.
Can you show me one more time how you squared the variance?
Yes. Now, when I show you how to square it, it's going to square this standard deviation. If I want to get the answer for number 39, I have to go back and do the one variable stats for list 5 again for me. Is that the one you want to see, number 39? So what I would have to do is do the one variable stats again for this data. This data I have in list 5. You have to do this step first, because when you do this step, doing the one variable stats, it stores this number in this location where the population standard deviation is. Now, if you want to get the variance, like on number 39 for this data, you have to go to the home screen, hit variables, stats is number 5, And then number 4 is the population standard deviation. And then to square it, all you do is you hit this button that's right above the log button on your calculator. It's where the x square is. And that's where we got the 20.8. If I would not have done the one variable stats first, or if I would have had the one variable stats for another list, let me show you what happens. Let's say I hit stat, calculate one variable stats for the data that's in list 1. And now I go back and I find the variance for the population. I'm going to square this number right here, so I hit 4 and then square. I end up with a different number than what I had here, because when I did this process, I had the standard deviation for a different list of data. That's why whenever you're finding the population variance, you start by finding the one variable stats for your list of data. Now, if you want to find the population variance, you have to find the population standard deviation first. That's what this step does for you. It finds the population standard deviation. Then you go to the home screen, and then you're going to hit VARs, and then you go down to stats, it's statistics, and then you go down to the sigma x, and then you're going to hit x square on your calculator, and then enter. But you've got to find the one variable stats first, then you can square the population standard deviation to get the population variance. But if all you have is sample data and you just want to find the sample variance, just hit second stat math, and you can use the variance and the standard deviation there. On number 41, we're asked to find the standard deviation for the given sample data. Round your answers to one more decimal place than is present in the original data. So we go back. It's just working more of the same type problems. We hit stat, enter. So I'm going to put this in list 6 since I've got list 6. So I've got 18. Once you have the data in your calculator, you go back to the home screen. This is sample data. We were told that this was sample data. Because it's sample data, all I've got to do is hit second, stats, and then go over to math. So that's what I'm going to do. I'm going to hit second, stat, math, and what I wanted to find was the standard deviation. That's number 7, and I'm using the data that I put in list 6, and there it is. We were told to round our answer to one decimal place more than our data value. Our data value are whole numbers, so what would I put down for my standard deviation? 5.4. Because it was sample data, I could kind of get the standard deviation without doing the one variable stats. I could have done the one variable stats and gotten it, but I would have used the sample standard deviation, not the population standard deviation. Number 42, find the variance for the given data. Round your answers to one decimal place more than the original data. Do the same thing. I've got to put the data in my calculator, so I hit stat, enter. I now want to clear this out because I have fewer data than what's already in the list. So I highlight the name of the list, hit clear, and then enter, and it clears the data out of that list. And then I can type in my data. Then go to the home screen. I want to find the sample variance. So I hit second, stat, math, and variance is number 8. And I want to find the variance for what was in list 6, because that's where I put my data. And I get 38.2. So the sample variance is 38.2. I used the wrong symbol here. This would have been S, not sigma. And this is S squared for the sample variance. Number 43, the following population parameters were obtained from a graphing calculator. So they've given us the output window for the one variable stats. Assuming the population is bell-shaped, approximately what percentage of the population values are between 43 and 67? Bell-shaped is what shape? What did I say we call that? Normal. And you remember normal data looks something like this. What number goes in the middle? The mean. The mean here would be what? 55, X bar is the mean. And then if we go out one standard deviation above and below the mean, which standard deviation do I use? This one or this one? These are population parameters. Which one of these do I use? Use the 12. So if I do 55 plus 12, that puts me where? And if I do 55 minus 12, that puts me where? So now I'm within one standard deviation of the mean, and what percentage of data lies within one standard deviation of the mean? 68% of your data. What rule is this called? 68, 95, 99.7 rule, or the empirical rule. It's given. That's why we sometimes call it the 68, 95, 99.7 rule, because if I would have gone out two standard deviations, this would have been 67 plus another 12 is 79, and 43 minus another 12 is 95% of your data lies within two standard deviations of the mean. Empirical rule, or 68, 95, 99.7 rule. Because 68% of your data lies within one standard deviation of the mean, 95% of your data lies within two standard deviations of the mean. And if I would have gone out three standard deviations, this number would have been 79 plus 12 is 91, and 31 minus 12 is 19. We would have had 99.7% of our data between these numbers right here, between the 19 and the 91. That's why I call it this 68, 95, 99.7 rule, but that's a little wordy, so we shorten it to the empirical rule. So here you're given the output for the population, and you had to pay attention that this was the population. That's why we said we use 12 for our standard deviation. So this is the mean. The mean goes in the middle, and then this next number here is the mean plus a standard deviation, the mean plus two standard deviations, and then the mean plus three standard deviations. And over here would be the mean minus a standard deviation, the mean minus two standard deviations, and the mean minus three standard deviations. This is the empirical rule. The 68, 95 is within two standard deviations, and then the 99.7 is within three standard deviations. This should be on your formula sheet. Guarantee you're going to want it. Number 44, the following population parameters were obtained from a graphing calculator. Assuming the population is bell-shaped, between what two values will approximately 68% of the population be? Well, if we draw our normal curve right here, what number is going to go in the middle of this normal distribution? 66. And if I add one standard deviation to that, I get, and if I subtract one standard deviation from that, what do I get? And what percentage of data lies within that one standard deviation? So when I ask you what two values do we use? We'd use 60 and 72. So this would work if we were between 60 to 72. What if I would have said not 68% but 95%? What would you have done? Add 6 more to this and subtract 6 from that, and we would say that 95% is between 54 and 78. You would add 6 here and subtract 6 here. You've got it. It sounds like you're getting it. The empirical rule's not that bad, and it comes in handy in the near future when we hit normal distributions in Chapter 6 and finding probabilities. Number 45, a paint manufacturer discovers the mean volume of paint in a gallon-sized pail is 1 gallon with a standard deviation of 0.05 gallons. The paint volumes are approximately bell-shaped. So what does that mean to us? Normal. Estimate the percentage of pails with volumes between 0.9 gallons and 1.1 gallons. So because it's a normal distribution, I'm going to draw a normal curve here. What number is going to go in the middle? The mean. We were told that the mean volume of paint is 1 gallon. And if I go out 1 standard deviation, what is that number going to be to the right? 1.05. And if I go 1 standard deviation to the left, what will it be? Do 1 minus 0.05, you get 0.95. We're struggling with that. And what percentage of data is this? 68. Are those the numbers that I was given? So if I go out another standard deviation, what do I get? 1.10, and then another standard deviation this way. Those are the numbers I was given, and what does that end up being? That's going to be 95%. So my answer here is 95%. 95% of the paint will be, or the volumes of paint will be between 0.9 gallons and 1.10 gallons. 99.7. Your book says almost all, and 99.7% is almost all. So I think for your book, you only have to worry about the first 2 standard deviations, the 68 and the 95. But if you ever take a statistics class in the future that uses a different book, the third one is 99.7. All right, number 46. I'm sorry, was there a question about this?
The distance between, I don't see where you're getting 95
The 95%?
Yes, the 95%.
The empirical rule says that 68% of your data lies within 1 standard deviation of the mean. So here's the mean, and then I added a standard deviation, subtract a standard deviation from the mean, right?
So that's 1.
That's 1 standard deviation away. This number right here, this distance right here, is 1 standard deviation. This distance right here is another standard deviation from the mean. The mean's in the middle. So I go 1 to the left and 1 to the right. 68% of your data will always lie within 1 standard deviation of the mean. Now if I go out 2 standard deviations to the left of the mean and to the right of the mean, and 2 standard deviations to the left of the mean, 95% of our data falls between those numbers. So that's where that 68, 95, 99.7 come in. It's the percentages of data that lie within that many standard deviations of the mean. The mean's this number right here in the middle. Makes sense now?
Yes, that makes perfect sense, actually.
Good. So make sure that you write something, because I said something that made it make sense. Make sure you write yourself a note right now while you're thinking about it, and I'll give you a minute to do so. If you're watching the video, you may want to pause the video if it finally made sense. Make yourself a note that you're going to put on your formula sheet so that you'll remember it at the time of the test. Yes.
It says, 95, what is that BT?
Between, that's my abbreviation for between. 95% of the paint will be between 0.9 and 1.1 gallons. That's just my shorthand. Number 46, a population has a mean of 21 and a standard deviation of 4. Find the Z-score for the population value of 29. Remember, the formula for Z-score is going to be your data value minus the mean divided by the standard deviation. So if we just drop the numbers we're given into this formula, what number do I put in for the data value? 29 minus 21 divided by 4. Now when you put this into your calculator, if you're going to use your calculator to do this, I want to urge caution. To put this into your calculator, you've got to use parentheses. So we would open parentheses, 29 minus 21, close the parentheses, and then divide by 4, because we want that difference divided by 4, not just that last number. And when we do that, we get 2. However, if you forgot to put in the parentheses, let me show you what you would get. You would get 23.75. This one's wrong because it's only dividing the 21 by 4 and then subtracting that from 29. Your calculator follows the order of operations, which means if you want that difference divided by 4, you've got to put it in parentheses. Or you've got to hit 29 minus 21, hit enter to get a number, and then divide that answer by 4, and it'll get you the same thing. Watch your parentheses on these. Z-scores are not hard, but people get them wrong because they don't know how to use their calculators properly. So that's my word of caution on this one. So we end up with 2 for our final answer here. On number 47, we're asked to find the third quartile. How are we going to find quartiles? The one variable stats finds all of our quartiles for us, right? So that's what we're going to do. We're going to put our, oops, I don't want that one there. We're going to put our data into the list in the calculator. So we're going to hit stat, enter, and I'm going to stick with list 6 since it's been working for me. So we put our data in, and I'm hoping I got it all right. We hit quit, and now my data is in list 6, so I'm going to hit stat, calc, one variable stats for the data that's in list 6, and then we hit calculate. And where do I find the quartiles? I got to scroll down. They're down here. And the third quartile is 75. So we would say that Q3 equals 75. These instructions need to be on your calculator formula sheet on how to use your calculator to do these things, like the one variable stats. On 48, we're asked to find the IQR. What is the IQR, the interquartile range? It's going to be Q3 minus Q1. If we were looking at a box plot, oops, on a box plot, this would be our minimum value, and the distance from the minimum to Q1 would be our first quartile. Our second quartile would go from Q1 to the median. The third quartile would go from the median to Q3, and then the fourth quarter of our data would be between Q3 and the maximum value. Now, the interquartile range is this distance right here. That's our IQR. And how we find that number is we do Q3 minus Q1. Knowing that tells me that I've got to put this data into my calculator and then find the quartiles. So that's what I do. And I'm going to delete the data that I have in list 6. So I'll clear it out and then type this in. And once you have your data in your calculator, you're going to go back to the home screen and then repeat the process of doing the one variable stats. And my data is still in list 6, so I'm going to hit calculate. And then we scroll down to see what Q1 and Q3 are. And I need to see the bigger picture here. So Q3 is 74, Q1 is 65. So to find the interquartile range, what I would do here is 74 minus 65. And 74 minus 65 is 9. So my interquartile range here would be 9. Number 49, Gina and Stuart are surf fishing on the Atlantic coast, where both bluefish and pompano are common catches. The mean length of a bluefish is 288 millimeters with a standard deviation of 51 millimeters. For pompano, the mean is 129 millimeters with a standard deviation of 40 millimeters. Stuart caught a bluefish that was 321 millimeters long. What is the Z-score for this length? Do you remember how to find Z-scores? It's the data value minus the mean divided by the standard deviation. So for this particular problem, what am I going to plug in for the data value? 321, the length of the fish. What do I use for the mean? Yep, 288, because that's the mean for the bluefish, and he caught a bluefish. And then we divide that by what? 51. And we put this into our calculators, and what do we get? I'm going to let you do it. I'm not doing it. Make sure you watch your parentheses. You get 0.65. So was that an unusually large bluefish that he caught? No. Not really, because the Z-score is 0.65. Unusual values have Z-scores bigger than 2 or less than negative 2. 2 for the standard deviation is our cutoff, because remember the empirical rule? We said that if we went out more than 2 standard deviations, that's 95% of our data. That middle 95% between -2 and 2 for the z-scores is usual. Anything bigger than 2 or less than -2 would be unusual. I didn't put a question like that on the review, but it is fair game. You did have questions like that in your homework, I believe. Okay, so I wanted to point that out on this video. Let me make a note that everything out here would be unusual, and everything down here, this would be unusually large, down here would be unusually small. All right, the last problem said Gina and Stuart are surf fishing. They're still surf fishing. We have different numbers, though, for the mean and the standard deviation. Now we're told Stuart caught a bluefish that was 286 millimeters long, and Gina caught a pompano that was 181 millimeters long. Who caught the longer fish relative to the fish's species? Okay? The only way to compare these two different fish that are two different species is to find the z-scores for both of them. So Stuart caught a bluefish and Gina caught a pompano. Let's find the z-score for each. What do I use for the data value for Stuart's fish? And what do I use for the mean for Stuart's fish?
You put 866.
I didn't I? So the Stewart's fish was 286 millimeters long. The bluefish had a mean of 261 millimeters and a standard deviation of 45. For Gina, she caught a fish that was 181 millimeters long, and the pompano had a mean of 156 and a standard deviation of 24. So we're going to use our calculators now to get the z-scores for each of these. So in my calculator, I'm going to hit open parentheses, 286 minus 261, close the parentheses, divided by 45. There's the z-score for Stuart, and now I do the same thing for Gina. Open parentheses, 181 minus 156, close the parentheses, divided by 24, and we get 1.04. So Stuart's fish was 0.56 standard deviations above average, because 0 is average, and Gina's fish was 1.04 standard deviations above average. Who caught the bigger fish relative to the species? Gina. Gina's fish was larger with respect to the species. WRT is my abbreviation for with respect to. We say that a lot in mathematics, so that's what I use for the abbreviation to save on the writing. All right, and this wraps up the review for the first exam, which will be on Wednesday. Make sure you have your homework done by Wednesday, because I will be grading it.